Welcome back. Today, we're diving into a crucial explainer where we completely untangle the fascinating worlds of automation, robotics, and artificial intelligence. We're using real IGCSE source material for this, specifically looking at Cambridge Computer Science Syllabus 0478. These three areas, this tech trio, are rapidly changing how our world operates, from how our food is grown all the way to how cars navigate city streets. We are going to break down the science, see exactly how these systems work, and look at the real-world advantages and disadvantages you need to know. And hey, before we continue, subscribe to our YouTube channel, Ace the Exams, at acetheexams_IGCSE to excel in your Cambridge examinations. Click that subscribe button and hit the bell icon right now. Okay, we've organized this journey into 6 clear parts, starting with the automation loop, moving through its applications, defining what a robot actually is, looking at real-world robotics, diving into AI, and finally, comparing expert systems to machine learning. Let's get right into it. Section 1, the automation loop. Let's see how hardware meets software to take humans completely out of the equation. So look at this definition. What's absolutely crucial here is the phrase without human intervention. An automated system isn't just some machine you turn on with a physical switch. It is a specific combination of hardware and software designed to do its job completely automatically once it's set in motion. The takeaway here? True automated systems do not need us to step in, press buttons, or pull levers once they're running. They handle it themselves. And this brings us to the continuous 3-step loop that drives literally everything from a nuclear power station to the adaptive cruise control in your family's car. First up, sensors constantly gather analog data from the environment, things like temperature, pressure, or infrared light. Next, a microprocessor takes that reading, converts it to digital, and analyzes it against pre-stored rules. Finally, if the data hits a certain threshold, the microprocessor sends a signal to actuators, which take physical action, like applying a brake or opening a valve. It's just a continuous, endless loop of sensing, thinking, and acting. Let's look at a concrete example straight from the source material, a massive crop irrigation system. Picture vast fields in Brazil. Humans simply cannot monitor soil moisture across miles of land 24/7, so the automation loop takes over. Ultrasonic sensors constantly measure water levels in the channels. This data goes wirelessly to a central microprocessor controller. The controller factors in the data, decides if the crops are thirsty, and if so, fires a signal to the actuators to turn on the water pumps. It perfectly manages a scarce resource, and no one ever has to step foot in the mud. Section 2, applications of automation. Let's see how this exact same loop builds into highly sensitive environments where human error just isn't an option. For instance, think about scientific drug development. Precision is everything, right? In this laboratory setup, an automated colorimeter sensor continuously monitors the color of a chemical solution. As acid drops in from above, the solution eventually turns from yellow to red. The very millisecond the colorimeter detects red, the microprocessor commands an actuator to snap the tap shut. It ensures flawlessly consistent results safely, and it reacts way faster than a human eye ever could. But, it's not all perfect. A common pitfall is forgetting to balance the pros and cons. While these systems maximize efficiency, give consistent results, and keep us out of hazardous environments, they come with a massive price tag. The initial setup cost is huge. Furthermore, they introduce serious vulnerabilities. A cyber attack on an automated agricultural system could destroy entire crops before a farmer even notices. Plus, they require enhanced, highly expensive maintenance from specialized technicians. Section 3. What makes a robot? Now we step up to our second technological pillar. We're taking automated actions and giving them a physical body. Before we get carried away with sci-fi movie robots taking over the world, we need to get strictly analytical. What actually qualifies a machine as a robot in computer science? And a really common trap, do software programs like chatbots or web crawlers actually count as robots? Well, let's look at the formal definition. Robotics is a branch of computer science that brings together the design, construction, and operation of robots. And it turns out those chatbots and web crawlers, even though we call them software bots, actually don't make the cut. Why? Because true robotics requires very specific physical criteria that a piece of code just doesn't have. To be a true physical robot, the machine absolutely must meet these 3 criteria. First, it has to sense its 3D surroundings using sensors or cameras to gauge things like size, shape, and weight. Second, it needs a degree of movement, wheels, cogs, pistons, or end effectors to actually lift, twist, or grip things in the real world. And third, it needs a programmable controller, a microprocessor brain that can be trained to execute different routines. If it lacks a physical body to move and sense, it's simply not a robot. Section 4, Robotics in the Real World. Let's see how these machines integrate into our lives, and specifically, the two different ways we interface with them. It is vital to distinguish between independent and dependent robots. Independent robots are completely autonomous. They have no direct human control and entirely replace human activity. Think of a rover exploring Mars all on its own. Dependent robots, on the other hand, require a human interface. They supplement human activity rather than replacing it. A great example here is a robotic surgical tool being carefully guided by a human doctor at a control panel. When we apply robots to fields like transport and medicine, the pros and cons are massive. Robotic surgery minimizes tissue damage, and autonomous transport reduces traffic because vehicles operate at peak efficiency. But we can't ignore the downsides. Beyond the steep costs, there is a real risk of de-skilling the human workforce. If robots do all the driving and operating, humans eventually lose those skills entirely. And hey, stop scrolling. Subscribe to our YouTube channel, Ace the Exams, at AceTheExams_IGCSE to excel in your Cambridge examinations. We've helped thousands of students improve by 2 to 3 grade boundaries. Join them right now by subscribing to at AceTheExams_IGCSE and turn on all notifications so you never miss our weekly exam strategy sessions. Section 5, The Brains, Artificial Intelligence. All right, let's dive into our final pillar. This is where machines transition from just doing repetitive physical tasks to actually simulating human thought. Artificial intelligence is essentially a collection of rules and data that empowers a machine to reason, learn, and adapt to stimuli, much like our own brains do. So, while a standard factory robot might just repetitively weld a car door, an AI system actually simulates cognitive functions. It replicates human benchmarks like deductive reasoning, recognizing speech, and understanding complex visual inputs. Now, you need to understand the 3 distinct levels of AI maturity. First is narrow AI, where a machine is superior to a human, but literally only in one highly specific task, like a computer that always beats you at chess but can't do anything else. Next is general AI, where a machine performs a task at a level similar to a human. Finally, there's strong AI. This is the holy grail of computer science, a hypothetical machine that completely outperforms humans across many, many different tasks. So, how does an AI actually think? Well, it relies heavily on deductive reasoning, drawing reasoned conclusions based on given data. For example, if an AI is trained on the rules for making a cup of tea, it doesn't just blindly memorize a recipe. It understands the underlying logic. Boil water, steep a substance, pour into a vessel. It can then adapt those exact same logical rules to an entirely new problem, like making coffee, without a human having to write a completely new set of instructions. Section 6, Expert Systems versus Machine Learning. For our final section, we're going to compare the 2 specific types of AI systems you absolutely must understand. First, the expert system. This is designed to act exactly like a human specialist. A user inputs a query through a user interface. Then, the inference engine goes to work. Think of it like a highly logical search engine. It applies rules to search a massive knowledge base, which is a giant repository of facts manually inputted by human experts. The system uses this to diagnose things, whether that's a patient's medical illness or a bizarre fault in a car engine, and it can usually explain its reasoning back to the user. In stark contrast to expert systems, which rely on rigidly inputted rules, we have machine learning. This is where algorithms are trained to learn from past experiences to make decisions. Instead of humans typing in facts, machine learning algorithms chew through massive volumes of complex data entirely on their own to spot patterns. A perfect everyday example: your email spam filter. It automatically categorizes junk mail because it analyzed millions of previous emails and learned the patterns of spam, not because a programmer sat there writing a specific rule for every single junk email in the world. And that brings us to the end of our explainer on the tech trio. We've seen how automated loops manage resources, how robots interact with our physical world, and how AI simulates cognition. As these technologies take over increasingly complex tasks, you really have to ask yourself, how will human roles evolve? Will our skills become obsolete, or will we adapt to interface with these new systems? Here's your final reminder: subscribe to our YouTube channel Ace the Exams at Ace the Exams IGCSE to excel in your Cambridge examinations. Subscribe right now to @Ace the Exams IGCSE and click that bell. Don't let another exam pass you by. Drop a comment below with your target grade for computer science and the biggest challenge you're facing. Our team responds to every comment. Like and share this video with a study partner. AC Exams, your Cambridge success starts here.